Okay, welcome, and now we're going to do some more examples here. Okay, so the first example, we're going to use algebra. So what they want us to do is they want us to do a substitution. Notice that in this case here, we want to simplify this, right? And so how do we simplify this? So what we're going to do is we're going to replace this with the quotient identity, right? And so what we're going to do is we're going to get 1 minus cosine squared x, not theta, 1 plus cosine squared x over sine squared x equal to 1. And then we're going to get what? We get 1 minus cosine squared x. Now I could change this to sine squared x, but let's hold off and see if we have to do that or not. So now I'm going to make this into a one quotient. Okay, so I'm going to make this into sine squared x over sine squared x plus cosine squared x over sine squared x is equal to 1. And now I can combine this, and I'm going to get sine squared x on the denominator, so I'm going to change this to sine squared x, because then that's going to cancel with the denominator here. So I get sine squared x plus cosine squared x all over sine squared x, and then the cosine squared, the sine squared x on the top and the bottom cancel, and I get, what do I get? I get sine squared x plus cosine squared x, which equals 1, right? So even if I take this off, you can see that I get the chain of equals, and I get the result. Now, what about this one here? This one here, what they want us to do is they want us to use a u substitution here to solve. So this is getting an idea that you can notice that this is what we call quadratic in form. So it has a squared, right? This is squared, and then this isn't, right? So we can write this as a, let's say a u substitution. So let u equal cosine x. And so then we can rewrite this as 2u squared plus u minus 1. And now we can see if we can factor this thing, right? And so how do we factor this thing? Well, we get what? This is 2 times negative 1, so we could use the AC method, okay? And so what do we get? We get 2u squared. So we get two factors of negative 2 that add up to 1, and so that's going to be 2 times negative 1. So we get 2u minus 1, right? So we use decomposition in the middle. This is part of the AC method. And then we use by grouping, right? So we're going to do factor by grouping. So we get 2u times u plus 1 minus what? We get u plus 1. So I just factored out a negative 1. Okay, or just factored out the negative sign. And so now what do I get? Well, now I can factor out another common factor of u plus 1. And so this will equal 2u minus 1 times u plus 1. And now what we can do is, when we're solving this, we can now put back in what our substitution was. So this becomes, well, actually, even before that, let's solve for u, right? Because if we plug it back in, let's just solve for u. This means that u has to equal what? U, because we can use the zero product principle. Let's say this is equal to 0, right? Well, that's not. But then we could solve for 1, we could solve for u and then put it back in. okay? And then what we could do is once we solve for u, then we could put in back in for cosine x and then solve for x and solve for the angle. Okay? And then the last one here, we notice that, again, one of the things we can look for is like a difference of squares, right? So this is 1, so it's the same as 1 squared. And then this is a perfect square, right? So we can write this as 2 cosine quantity squared, or cosine theta, minus 1. And this is sort of like 1 squared, right? And so now, since this is a difference of 2 squares, we know we can write this as 2 cosine theta plus 1 times 2 cosine theta minus 1. And then what we could do is we could use u substitutions here. Again, we could use a u substitution and solve for u, right? Or we could use a u substitution back here and then solve for u and then solve for the angle once we back substitute in for cosine theta. So we could let u equal cosine theta here, find out what u is equal to, right? And then solve for u. But again, this is not set to any equation yet. Okay? So again, this is just setting the stage of things that you can do to help solve these equations that we're going to start doing. Okay. Have a great day.